Hi, my name's Andrew McLaren. Today we're going to talk about redox reactions, which have two parts. One part where something is being reduced, and the other part where something is being oxidized. And we're going to really talk about how to clearly identify these parts so that you don't get your wires crossed halfway through the problem. I've got another video on what is an oxidation number and contrasting that with formal charge. But for today, we're going to really be trying to focus on like labeling these parts in an oxidation problem. So the first thing that I want to clarify, and we'll do this with an example soon, is when something goes through reduction, it is an oxidizing agent because it is doing that oxidation to the other thing. So if something itself is oxidized, it's a reducing agent, and vice versa. So this word agent means that it's doing to another, or it's acting on the other chemical. And I really want to emphasize that I really like Leo says GER because that stands for loss of electrons is the oxidation, and the gain of electrons is reduction. So that this really clarifies that we're talking about electrons being gained or lost and not the oxidation number, because if something is gaining electrons, it's actually going down in its oxidation number. So it's really important that we're clarifying the electron here with that E that's present in both of these. Oil rig, it's not as good because it'll say like oxidation is loss, but then it's like loss of what? And same with the reduction is gain, but it's gain of what? So those, I don't really like oil rig as much as Leo Sisger for that reason. And if we look at an example of this, if we look at some reaction, we could have the. So if we look at a reaction, we could be talking about something like lithium and oxygen reacting to form a lithium oxide. There should be, for this, I believe that there's going to be, because lithium will typically have a +1 charge on it, which is kind of like oxidation numbers. If you need to get any clarification on oxidation numbers, I have a whole separate video on that. But for these oxidation numbers, I would say that lithium is going to be 0 at first. Oxygen should also be 0 if it's bound to itself. If it's a neutral charge or it's bound to itself, it should be 0. And here we've got a -2, and then each one of these is +1. So if you were to look at the math, there's 2 of those, and that's being added to this -2, and there's only 1 of those, so those cancel out, and the whole thing is neutrally charged. So that's the oxidation numbers. Now the question is, how do we think about Leo says GER in the context of this problem? And my trick is to basically write out a line, like sentence by sentence, of very clear, easy to track things. So I would start with this lithium and say that lithium has increased the oxidation number. So its oxidation number has gone up. So that's kind of like charge. And so if its oxidation number has increased, it's actually lost electrons. So we can say lithium lost electrons. And then if we are talking about loss of electrons, we're going to say that that would be for our oxidation here. So for in this video, I think I'm going to have oxidation be red and reduction will be blue. So just kind of show you that in this context here, once we've got things labeled clearly. So we've got lithium, oxidation numbers going up, there's a loss of electrons. We've got this loss of electrons here. So I know loss of electrons, so lithium, which lost electrons, is oxidized. Therefore, lithium is the reducing agent. So it may seem like a little bit much, but writing this out where you say what's going on with oxidation number, what's going on with the electrons, and then what's going on with the oxidation and the agent, or like the process and then the agent, is really useful because then you can see it, you can check each step and be like, yep, That is correct. That matches that. That matches that. And that matches that. Because each time you go to the next one, that is a place where your brain might cross the wires. If you're doing a hard test, it's very easy to accidentally say oxidation when you meant reduction, right? So if we have a loss of electrons, it's kind of like charge going up. And you could even, if you wanted to write charge here, just to help clarify, that might help out a little bit. So same sort of deal here with oxygen here. So we can say oxygen has a decrease in the oxidation number. So oxygen has gained electrons. And so we've got that gaining of electrons, which is our reduction. So we've got reduction happening here. And then we can say O is reduced. O is oxidizing agent. So this gets at the whole idea of like, well, what is oxidation? Oxidation is when something reacts with oxygen. So something is oxidized when it reacts with oxygen. So you can see this word, like lithium is oxidized because it's reacting with oxygen. So the something that is oxidized reacts with oxygen. Oxygen itself is an oxidizing agent. It's a little bit weird. People kind of get their wires crossed on here. And that's why I really like the Leo says GER, because it just kind of takes care of that component of like, well, what's kind of going on with each process in terms of the electrons. And it's very, very clear. So we've got one reaction done here. I'm going to do another one. Sometimes you'll have something like this where you've got like C2H4 reacting with oxygen, and some things are being reduced and some things are not being reduced. So if we were to look at this reaction, it's probably going to form some CO2 and some water in the big picture, and we can get this balanced pretty easily. So I think we'll need 2 of those, and 2 of those for every one of these. And then that means we've got, what is that, 4 oxygens, another 2, so that's 6. So we've got 3 of these. So we've got this balanced equation, but it's like what's going on with our numbers here. So we've got Leo says GER, just to clarify that what's going on with our electrons in this context of this problem. And let's get our oxidation numbers here. Luckily, there's again, oxygen, kind of similar, that's 0. These do have some charge on them. If we're thinking about oxidation numbers, hydrogen should be a plus 1. And then that means that the carbon here is going to be a minus, what is that? -4, I think. Yeah, because that would be 1 times 4 plus, no, the 2 times -4 here. So this is going to be a -2 for the carbons. So each one of these carbons would have an oxidation number of -2. This is a little bit different than what we see over here. So the oxygen now, each one of these oxygens should have an oxidation number of -2. The hydrogens are +1, and that should cancel out. And then the carbons here, it looks like this is +4. So it goes from a -2 to a +4, and this hydrogen goes from a +1 staying as a +1. So hydrogen isn't being reduced or oxidized. It's actually the carbon and the oxygen that are of interest here. So we can talk about this similarly, where we're saying like carbon has a change in the oxidation number. So oxygen, or carbon, looks like it's increased its oxidation number. So carbon has lost the electrons. And if we're talking about a loss of electrons, that means carbon is, if we're talking about Leo, loss of electrons, then that is oxidized, meaning it is the reducing agent. So if we then think about like the colors, we were doing this as red earlier, so I'm just gonna switch that over to red to just be consistent. You could have reduction be red, that might make more sense. Um, I think it kind of is justifiable doing this red because it's like it's losing electrons, so it's kind of like a loss of something. But either way, it doesn't really matter color coding wise. Then we can talk about the hydrogen. So hydrogen has no change. So there's no process in terms of the oxidation reduction here. And then the oxygen has a decrease in the oxidation number. So oxygen has gained electrons. And then if we're doing Leo says good, gaining of electrons is reduction. So oxygen is reduced. Oxygen is oxidizing agent. That's basically the trick done the second time, so you can kind of just wrap your brain around how it's similar and a little bit different between these two problems. In problems like this, not everything will be reduced or oxidized. Usually something is going up and something's going down. If something's gaining access to electrons, it has to get it from somewhere. So there should be an appropriate like pairing between reduction and oxidation, hence the name redox, which kind of combines the two. But it's just a track of keeping track of these different terms and how they relate. And I found that just doing a nice linear line is like the easiest way to help people with that. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.